Hey, let's look at what's next. Assuming you've got all your K-maps completed and you've got all your sum of product expressions written out. I'm going to show you in my notebook when I did this for myself. Well, maybe I'm gonna hold off and show you that in a second. Okay, so the next thing you're gonna do is you're gonna hand draw the circuits. Color coding can be super helpful. So I'm gonna create basically what would be like a bus with my inputs having X not X, Y not Y, etc. And I'm going to try to keep them color coded where my Y's are kind of related colors, but one's darker than the other. So kind of all my ones are going to be dark and my nots are going to be the lighter color. Just something that is easy for me to remember. Okay, so from here we're going to hand draw our circuit, and you basically have the request to use out of the 7 of these, use NAND, the universal NAND gates on one of them and the universal NOR gates on another. So 2 of the 7, and then the other 5 are just going to be your regular AOI logic, ANDs, ORs, and inverters gates used. So I think I would look at trying to pick out which one do I want to use for my NAND and which one for my NOR, and just kind of pick one, okay, in a way. We could spend a lot of time doing analysis trying to find which one's going to be the most efficient, but for right now we're really just trying to illustrate for ourselves and kind of remind ourselves that it's a possibility to use NANDs instead of AND, OR, and inverters and NORs. Now, how I might choose, though, this is where I'm going to show you mine, from when I did mine, is that I had all my expressions here, okay, is that I went through looking for any products that I had in common, or even any sums that were in common. And I don't think the colors come through great on the camera, but if I had stuff in common, my idea was that when I go to draw my circuits, I don't need to recreate each product again and again. So let's just take, for example, maybe kind of easy to see in the first one, I have in purple, I have the product XY. So that's for LED A. And then in LED B, that expression also needed the product XY. And so I underlined that common thing in purple. And I started looking for anything that I could find that was in common. And then, you know, you can even see the underline of the sum of these two terms, a YZ or XY, YZ or XY. I had both an A and B as well. So I had even more stuff in common. As I found stuff in common, what I realized, right, is I don't need to recreate the same exact logic over and over again. Once I've created the logic for A, it's good enough for B as well. And so while I'm going to create a circuit for B that'll have kind of an output B wire that goes into the 7-segment display, I can grab off of where I've already created a circuit. If I've already created the logic, right, I can grab it and use it. So my thinking here to you is if you do a little bit of analysis and looking for you know, common sums and products first, that you might find a circuit that has less in common with others. And if it's less in common, then it's not going to hurt you as much to take that one and make it your NAND gate circuit or your NOR gate circuit. I hope that makes sense. Going just a little step further, if we look over here, you can see, so in the pink, I guess I'll use, that's the sum of these two products of YZ and XY, and just so you can see. So I had YZ, okay, created with the ANDs, XY created with an AND gate. So I have YZ into an or XY, and right here I have that expression, YZ or XY or YZ. And as I drew it out, I used my same color, so I've got that in pink as I had underlined there. And that gets used to create this output for A. But I needed this exact same logic in my, not as the final output for B, in creating the output for B. So I didn't recreate B from the beginning over here. I grabbed that and brought it down and mixed it in with the other things that I needed to make up my circuit, which was just this one other product of not X, not Y, not Z. So you can see I created that here, not X, not Y, and not Z. So I had grabbed not X and Y product from above somewhere else, and I brought in the not Z to get that product of all three, and then ORed that. So this will save you time, because in the end you're going to have used less gates, and if you have less gates, it's just less chips on your breadboarding, it's less wires, it just saves quite a bit of time. But it really does require that you take your time and think and label everything very carefully. So this gives you a little view into when I did mine, okay, when I took the class. And so this is kind of the beginning of how I'd start with creating my hand-drawn circuits, is maybe a bus line. You can see that I didn't take up that space either, so I used this left edge and just made it dark in my notebook, and I just said this is going to be a bus that contains all of them, where I can kind of pick any of them up. So maybe another way to do it, just for the sake of saving space in your notebook. Okay. So that just brings you back to, identifying which one of these might be my NAND and which one of these might be my NOR. And then once I've done that, I think I would go ahead and have those either at the very top or at the very bottom, and keep the rest of my AOI stuff together. So, okay. All right. I hope that helps you guys get a good start.